Welcome class. Today we're going to start 10.3a. All right, so we're going to dive into more operations with radicals today. However, first we're going to do some more reviewing for finals. So when we're told to solve x plus 12 and 2x minus 10, well, if you notice, it is already actually in factored form. So remember, when it's already in factored form, all you have to do is take your two pieces, set the first parenthesis equal to 0, and the second parenthesis equal to 0. And now we can solve them individually. So for this one, I'm going to subtract 12 from both sides. This one, I'm going to add 10 and then divide by 2. When it comes to just factoring, like the next one, remember quadratic trinomial means you're getting two parentheses. Where is that 2x squared coming from? Well, that 2x squared is coming from 2x and x. Now that 6 can come from either 1 and 6 or 2 and 3. And so to see the combination that we need to make this work, I'm going to put a plus 6 and a plus 1 because that gives me 1x plus 12x, and that gives me the 13x that I'm shooting for. So that means that that is really the true factored form. Now, I want us to look at adding radicals today. So, in adding radicals, think of it like combining like terms. So 3x plus 5x, well, we know that that is 8x. Well, the same actually holds true, 3 square roots of x plus 5 square roots of x. Well, really, we do the same thing. It's going to be 8 square roots of x. Think of it like counting the square roots of x. So to add and subtract radicals, you must have like terms. And by like terms, I mean the same thing under the radical. If they're not the same radical, they're not like terms. Now, the important thing to know is sometimes you need to simplify first. So look at this example here. You have 3 radicals, and all of them appear to be different. However, once you simplify each radical, you pull out the perfect square from each radical. Now notice what happened. All of them had that same base radical once you pulled out the perfect square. So, the very, very important first step to all of these problems is you have to simplify first. All right? If you can take a perfect square out of the radical, you must do so. So let's take a look at some examples. Now in these ones, I've highlighted everything that is a like radical. So we have 6 square roots of 11 plus 9 square roots of 11. So I have 6 in the first one, 9 in the second one. So that's going to give me a total of 15. Well, 15 what? 15 square roots of 11. I have 1 square root of 3, and I'm subtracting off 5 square roots of 3. So again, we have a like radical. The same thing is inside the radical. Starting with 1, I'm taking away 5. So that'll be negative 4. Negative 4 what? Well, square roots of 3. Seven square roots of 2 minus 8 square roots of 2. Again, same thing. We have the same thing under the radical. So 7 minus 8 is a negative 1. Then we're talking about square roots of 2. 5 square roots of 5 plus 2 square roots of 5. So again, we're talking about like terms. Both of them are square roots of 5, so we can add them together to be 7 square roots of 5. So those are the absolute basics. Now, when we go back, and now we're looking at more difficult ones, 4 square roots of 7 plus 2 square roots of 28. What I want you to realize is that square root of 28, you can actually pull a 4 out of. Okay, so remember, when you're dealing with things where you can pull out a perfect square, you must do so. Because really now, we have 2 times 2 square roots of 7, or 4 square roots of 7, because we can do 2 times 2. So if that 2 square roots of 28 is 4 square roots of 7, we have just turned our problem into this. And now we have two radicals that are the same, meaning we can add them. 4 plus 4 gives us 8. And we're talking about square roots of 7. All right, now for this next one. This time both of them can be simplified. So out of 32, we can actually pull a 16. And out of 18, we can pull out a 9. So we're still always looking for those perfect squares. Well, this will become a 4, and that become a 3. So here, 5 times 4, I have 20 square roots of 2 here. 4 times 3, I have 12 square roots of 2 over there. So altogether, I have 8 square roots of 2. All right, now today you're in luck. That is actually all that we have to get through. So thank you for joining me. And please make sure that you have all of these notes taken, written down, so that when you come back to class, we can do our practice work.